Good morning, doctor. My name is Wong Kha Chun. I'm from Group 5. I'm the presenter today. Before we proceed, let me just recap some of the definition of the Fourier transform. Fourier transform is mostly heavily used in the analysis of the signal and the system. And we can see in our this assignment 2, we mostly discuss about the signal and the system of sound or the music or the sound. And Fourier transform converts non-periodic continuous signal in the time domain in the continuous signal in the frequency domain. In this assignment, Fourier filter will be used, and it divides into 4 parts, which is low pass filter, high pass filter, band pass filter, and band stop filter. And it works by taking a Fourier transform by attenuating of amplifying the specific frequency, and finally inverse the transforming the redux. So first and foremost, I will introduce the relationship between the Fourier transform and the filter. Fourier transform is the product of the filter or the function, the product of the Fourier transform of the original element and the filter function, which designed to reduce the frequency of Y versa, is the Fourier transform or the improved filter, which means we can get our new improved image by just multiplying these two elements inside. After we get our Fourier transform, we will inverse it to get our improved image. So we will start to do our analysis by just looking at the simplest analysis, which is a low pass filter. As we can see for the low pass filter, it will cut off from the main file. We can see the low pass filter will have the cutoff frequency at 1100, and whereas our high pass filter will have the cutoff frequency at 8000. So what we can see the difference between the high pass and low pass, which is the low pass will only keep the low frequency and cut off all the high pass frequency. This what I'm explaining this. And low pass frequency will maintain stable at the low frequency, we show at this, and will keep unstable at a high frequency from this until this. For the magnitude of the low pass filter will be the same. It will keep smooth at a low frequency and will become unstable at the higher frequency. For the time plots of the input and output Laplace, we can see that from the equation, frequency is equal to 1/t. So that means the lower the frequency, the higher the time slope. We can look to compare between the low pass filter and the high pass filter. As we can show, the low pass, for the time slope for the low pass filter, the time slope is between around 2 to -2, whereas the high pass filter is just from the 0.5 to -0.5. Then next we will proceed to explain the impulse response. As we can see, the graph shown is a sine graph. It's actually generated of compute of when using the Fourier transform. Before we proceed this, let's just recap. When we have the low frequency, we will look at this picture first. When we have a low frequency, which means like this, for the low pass filter, we will get a sine graph. We will get a sine C equation. After that, we will generate this graph, which is for the low pass filter. When if in the high pass filter the frequency the frequency will be higher, so will be generate from a higher rise of frequency. After that we will get this kind of graph, which is wherever the SS, the positive value on the x-axis will be set at the negative value, the magnitude of the negative x-axis. So now we proceed to the band stop filter, band pass filter. Band pass filter is actually the combination of the low pass filter and the high pass filter. It's actually the same. As we can show, the band pass filter only stable in between the frequency. We can show at the lower frequency it will remain unstable, while at the high frequency it will also at the unstable stage. Phase degrees also explain the same. When we look at the input and output spectra of the band pass, it shows that the frequency only keep at the middle of the frequency. For the high frequency and the low frequency, it will be cut off. And this is impulse response of the band pass filter. So we will proceed to the band stop. Actually, the band stop filter is the inverse of the band pass, which means that the filter will filter will be like this. The frequency response or the band stop will be like this. From this graph, we can see that the band stop filter will remain stable at a higher frequency and at the lower frequency. We can compare it with the band pass. This shows the difference between the band pass and the band stop. So this shows the analysis of the band stop. In conclusion, we can conclude that by using the Fourier transform, in the low pass filter, the sound will be the new sound. Low pass filter will reduce the amount of the noise in the data, which means that we can get a new sound at the lower frequency. Whereas at the high pass frequency, we will get the vice versa from the low pass filter. I think this all about the analysis about all the low pass, high pass, band pass and the band stop filter. Thank you very much for this.